Thank you. I am Carl Drews. I'm from Boulder, Colorado, and I'm happy to be here. Our discussion today for the next half hour is going to be Exodus 14. This is a single chapter of the Bible, and I have spent 5 years studying this one chapter of the Bible. It's a very interesting chapter. The operative point here is Exodus 14, 21 to 22. These are the verses which talk about Moses stretched out his hand, drove back by a strong east wind, the sea was dry land, and the waters were divided. So that's especially what we're going to look at here. How can we study a miracle with science? Isn't a miracle the opposite of science? Well, the miracles of the plagues are all including a natural component, and science can study that natural component of the narrative. As we've already mentioned, from plagues 1 to 6, it's an environmental sequence, kind of an environmental cascade there. And so the natural component continues. For the parting of the Red Sea, we have the wind and the water is the natural component. And when you have wind moving water, that is oceanography. Science has been analyzing the narrative in Exodus 14 for quite a long time. This is a real event recorded by General Tulloch in February 1882. He described something that's quite reminiscent of Exodus 14. He was working out by the new Suez Canal, and Lake Manzala was nearby, and suddenly a wind blew up from the east and blew all night long. When he went out in the morning, the Lake Manzala was gone, and he saw the fishermen walking around instead of moving their boats around, and it flashed to him that this is like that thing I read in Exodus. And every 2 or 3 years, there's a hurricane that moves up the west coast of Florida, and it will dry out and blow out Cedar Key Harbor and other places, and the news reports record a few people saying, this is like the crossing of the Red Sea. So this kind of thing does happen from time to time in modern times. Here's a diagram I made during my master's thesis of storm surge and wind setdown. The pile of water you see on the left side of the diagram is the body of water that has blown out of what I called Flat Lake, which is 2 meters deep, and the arrows show the circulation in the body of water. It has piled up on the downwind side about 2 meters, and on the upwind side, it has cleared out the bottom of the lake to a depth of about 2 meters, and there is Major Tulloch standing there and marveling at this event that happened. So this is just a sort of simple diagram of storm surge here. And wind setdown. Storm surge is the high side, wind setdown is the low side, and they have about the same magnitude in terms of meters displacement. Storm surge and wind setdown are also observed regularly on Lake Erie on the US-Canada border. This is a bathymetry map of Lake Erie, and as you can see, the area around Toledo is very shallow, and so that experiences wind setdown, and when a strong wind comes from the west, the lake will be cleared out to a distance of kilometers. And there is a corresponding surge at Buffalo, but not as big because the area of the lake is deeper over there. I'll call your attention to this sand spit along the north shore. That is driven by a longshore drift and by waves and currents, and a plume of sand and sandbar is making its way out into the deepest basin of that lake. So this shows how you can have sandbars going out into deeper water. And so we'll come back to this when we look at the reconstruction of the Nile Delta. Thanks to Michael Lazar, I think it was, we've seen this diagram before, the one on the left. This is the bathymetry of the northern reaches of the Red Sea. So that's the depth there on the left, and it's all red because it's washed out the color scale. It's all very shallow there. The Gulf of Aqaba is quite deep, and as Michael mentioned, there is bigger storm surge and therefore wind setdown in a shallow body of water. So if you look at Aqaba, there is not any appreciable change there, either in surge or setdown. So yet another reason for not favoring the Gulf of Aqaba as a place for the crossing if it is wind setdown. On the other hand, if you look at the northern reaches on the left side there at Suez, where all the purple is, that's about 1.7 meters of surge there. So if you're Napoleon and you're about 1.7 meters tall, you could nearly drown. And this is exactly what happened to him during a high wind episode when he was crossing the shallow waters there. So look at the Exodus 14 text, and our idea here is to look at the natural components we have here. I focused on Exodus 14, which is the narrative. Exodus 15 is the poetry, and they are marked at the documentary hypothesis as different sources, and that made quite a bit of sense to me because the poetry is a different source from the narrative. I also see in a couple places Moses putting out his hand, and that's marked as a different source as well by the documentary hypothesis. So that is not a natural component, that's his signal. So that's, I guess, a spiritual component you'd call that. So let's take a look at what we can extract from the text. Strong east wind blowing from the east, not toward the east, but from the east, blew all night long. This is the spring equinox. So all night long would be about 12 hours. And we have a reference to dry land, and we don't know whether that meant there was no standing water or whether it was dry to the touch, which came up several times when there was media coverage of the research. But what it means is there's certainly no standing water there. No escape, a rapid return wave. So Pharaoh maybe Pharaoh, but definitely his army are going to get stuck and trapped here. Here's a map of the Sinai. And for all sources who believe that the crossing happened, it happened somewhere on this map. And it happened a lot of proposed places on this map. I looked at the margin of the Sinai, and just about every body of water has been proposed by some scholar at some time as the crossing. The single exception is the Dead Sea. Nobody says they crossed there. So Dead Sea's safe, but every other part of this has been proposed. When I look at this as a graduate student looking for a project in oceanography, I see the east wind. It has its most effect if there's a body of water oriented east-west. Most of these here are oriented north-south, so they're not going to work. The Gulf of Aqaba and the Gulf of Suez are more north-south than anything else. Even the Bitter Lakes are kind of north-south. But we see these two big lagoons on the coast of the Mediterranean, Lake Manzala and Lake Bardawil. I don't have time to go into Lake Bardawil, so I'll focus on Lake Manzala for this talk. We can talk about it later. So what did this look like in 1250 BC? So I am trying to get a digital terrain map 3,000 years ago. And I can send this to you, Steve. There's no Suez Canal. The delta front was farther south then. The delta's been prograding forward. There are 7 branches of the Nile then, rather than the current 2. Most importantly, a vigorous sediment load coming from the Nile River, which has now been choked off by the construction of the Aswan High Dam. And there's smaller canals. So along the way, I found this schematic map of what people thought, James Reynolds thought the Nile Delta looked like at the time of Herodotus, based on his writings, his verbal writings. So James Reynolds is constructing a map here. And I looked at the eastern portion of it, and there's this very large lake of Tanis. When we blow an east wind here, something will happen at the east end of the lake of Tanis, and there will be some wind set down there. And I also noticed that the Pelusiac branch of the Nile joins the lake of Tanis there and then flows out the Pelusiac mouth. I also saw I don't know if you can see this real well on the screen, but down below on the lower right-hand side, in the middle there, it's Magdalum. So here I started to get excited and say, could that be the Migdal of Exodus 14:2, between Migdal and the sea? So I looked up James Hoffmeyer, who was already my source for many of these things, sent him an email and said, could this be the Migdal of Exodus 14:2? He said, yes. So I'm really excited at this point. And what I would call here for this conference is this is transdisciplinary convergence. Using only the methods of oceanography, I have found a spot which is likely for my further experiments. Using only archaeology, James Hoffmeyer has located a route at a certain place, and we converge literally within 10 kilometers of each other. So very happy about that, and thanks to Steve Mosher, who's here today, for the geology behind both of our research. So we want to not just recede the sea, but we want to part it, because as Michael Lazar pointed out, if it just recedes, Israelites go across and the Pharaoh and his army can just go around. So we want to part it. So how would this work? What hydraulic mechanism? We saw one earlier about an underwater ridge. I'm going to suggest that the bend in a body of water is better. This is another idealized scenario there, where there's a bend like an oxbow lake, and when the wind blows, the water is going to shift downwind and split at the point of the bend. If you're Moses, you are going to see water on your left and on your right, and you can run across, and if you're fast enough and the chariots following you are delayed enough, they will get inundated by the return surge. So let's complicate that a lot and go back to the reconstruction of the lake here. The bend of the body of water is between the Lake of Tanis in the upper left, and in the lower left, the Pelusiac Nile. That's got to pull back, but the water is going to be streaming in from the Mediterranean Sea, and that might mess everything up. So I really can't just talk my way through this. I have to have a high-resolution model to see what's really going to happen here. So I used many sources here for reconstructing the geography. Notable ones: James Hoffmeyer, Stephen Mosher, Manfred Bitak, Daniel Jean Stanley, who put a lot of cores took a lot of cores out of the Nile Delta. Also notably, the Shuttle Radar Topography mission came online shortly before I was working on my thesis, so that gave me a high-resolution 86-meter grid of all the terrain there. And for Smith and Sandwell, that was the underwater. That's 860-meter grid resolution and Google Earth. So I assure everyone on this list, I have examined every square centimeter of your maps very carefully. Here is a picture of the Nile Delta today from the Shuttle Radar Topography mission. If you look closely, you might be able to see some strange-looking straight lines there, kind of going up on the left and then across. That's where the different passes of the satellite acquire the data, and then they have to stitch it together. And they can't do that perfectly, especially when somebody moves the color scale down from -7 to 20 meters and sort of squeezes it all towards sea level. There's another line in the upper right there. What is this? That one's bent a little bit. That is the Pelusium line, and that is the northwest boundary of the Sinai Plate. So that is going to give us some stability amid the shifting sands of the Nile Delta. So that is a very important line for us. It's a tectonic plate boundary. When I looked at maps by Mosher, Hoffmeyer, and Bitak, there was an open sea designation to the north of Heboah 1 and 2, and this puzzled me. To the left of it, to the west, there was a sort of a ragged coastline there, and I respectfully offer a counter-proposal for this geography along the margin of the Nile Delta. I claim that you cannot have a ragged coastline like that along the margin because this is a wave-dominated delta. There is always going to be pressure from the waves and from the wind to make a shingle beach, a barrier island, along the edge of the delta. It will not be inhabitable, but it will be present. And there was some land north of the Pelusium line and west of Heboah 1 and 2. So this is my proposal, and I will just show that description in a schematic here. So this is my schematic of what I am proposing that it looked like. Pelusium is an anchor, and so is Ketewa and Heboah 1, but north of that, things are shifting around. Sethrum was geologically a very new land, and probably pasture land, kind of marshy, but it did have this barrier island to the north. And the Ketewa Gap there, where the Pelusium line goes low and was underwater at the time of the Exodus, this is the spot that I'm going to investigate for the crossing. So let me show some evidence for this, for my proposal. Even today, when the Nile River is starved of sediment, there are these plumes of sandbars coming off the Damietta promontory and moving to the east. It's still happening even though there's no sediment supply, so even more it would happen when the sediment is coming from a sediment-loaded Damietta branch and the other branches. Also, this is the same thing that we saw on Lake Erie. We have a map of this area here. This is published several places. This is the battle relief of Seti I at Karnak. And I've had to flip it upside down here, the map I just showed you, and to match it with these features on his battle relief. If you look on the right side by the red arrow, there are substantial features there. So some of them are adoring slaves, welcoming back the conquering hero. I don't know exactly what the others are. Perhaps the archaeologist can help us interpreting those, but it seemed to me that there were substantial features there to the north of the Pelusiac branch and the Pelusium line. Came across this term, Ta Dinit, the dividing waters. Gardner identifies one of the bodies of water that I just showed is called Tanis, the dividing waters, because they sundered Egypt from the desert. But I wondered, what if these waters themselves divide? What if this is a natural phenomenon that happens every few generations, and perhaps this is something that's recorded in the toponym, and maybe at the time of Moses, the elders, somebody might say, oh yeah, this happened long time ago, and I remember it being told about it when I was a kid. So just a tantalizing hint at this point. We saw earlier diagrams here about the delta front cross-section. This is the actual plotting of the front. It's sort of shallow until you get to that barrier island, and that is a distinct boundary with the open sea. Then it plunges off rapidly. So this is not a delta where the mangroves just sort of drift off into the deeper water. There's a definite geographical boundary there at the delta front. And this can be a source of tsunamis as well. So here's my terrain modifications. I drew this with Google Earth, and then I have a Python script which does a flood fill algorithm of those polygons and makes it all 2 meters deep. So I can modify terrain fairly easily, draw things, and be able to have you download it and look closely at it to see where you think the boundaries are and if you agree. So this is downloadable, and this is done with especially with Google Earth and with Python. So I give you the digital terrain model from 3,000 years ago. I've made the Lake of Tanis there, and I've made the bodies of water 2 meters deep, except the Bala Marsh, which is a 0.5 meter deep. And then I have carved off the front of the delta so that it will slope down realistically according to what we know of the delta today. I anchor the top at Damietta there, and then the barrier island goes smoothly curving toward Pelusium. So this is the model, and it's in a netcdf file for use and running by the ocean model. I use the ROMS ocean model and the Bluefire supercomputer. This one is one that was at NCAR a few years ago, and there's a lot of grid points. The domain is like 1,000 by 1,200 grid points, so there's a lot to calculate. And here are the results. At the Ketowah Gap, X marks the spot of the proposed crossing. There is dry land there. The brown is dry. I have called it mud flats. We can talk some other time about whether it was dry to the touch or not. The water pushes back, and the crossing itself, 3 kilometers long, 5 kilometers wide, and remains open for 4 hours. And I looked at that 5 kilometers wide. Everything I've ever seen in movies or art shows this narrow crossing. So I looked back at the text and I said, the Bible never says it was narrow. So if ocean modeling can do just one thing for biblical interpretation, it's that it doesn't have to be narrow. And you can push a lot of people through there if you wish, but that's the metrics of the crossing I have there. The wind here was at 62 miles per hour, and so I went back and forth with my thesis committee saying, what's the strongest wind you can walk forward into? And they said, well, I've been up on Mount Washington, I've done this and that. They, all 4 of them agreed, we will defend 62 miles per hour. And so that's making forward progress. No fun, but you can make forward progress. And then at NCAR, we have a weather lab on top of my building. And so when we have Chinook winds in February, I can go out in the parking lot and walk into like 65 mile an hour winds. And it's possible, it's no fun, your eyes burn, but you can make forward progress. Walls of water. I am going to interpret this as a metaphor for protection. So there were walls, the water on both sides of them was a wall and kept them safe from flank attack by the chariots who were trying to approach them from behind. It's not going to be a vertical wall of water. If you look at the word Chalma in the Old Testament, it's usually a wall of a city, but with David and Abigail, it's a wall of fighting men around her, keeping her safe. And in Nahum 3:8, it is the Nile moat around the city of Thebes. So an unusual, but still there is precedent for that interpretation. So let's push this model as far as we want. Let's look for some debris. The return surge, according to my model, passes first from south to north through the Ketowah Gap, and then you get in the lower diagram the surge coming from the Lake of Tanis. So anything, chariots that are left in the crossing, struggling there, will get pushed north and then will get pushed up against sort of the front of Ketewa there on the coast. So any debris, according to this model, would be found around Tel Ketewa on the north slope and lesser on the southeastern slope there. Also notice currents are 3 meters per second, which is a lot for water. There would certainly be a whirlpool forming at the strait between Hebewa 1 and Hebewa 2. So that supports this another toponym, the place of the whirlpool. So here's the route of the crossing. They cross at Daphne on I guess that's the Shihor Lagoon or maybe the Lake of Horus. Then they go north and they get stuck. And the crossing is from the point B, Pi Hahiroth, over to Tel Ketewa. And then they go south from there. So I'm going to zoom back a little bit. So the Bible says there's this turn back, and because they're blocked. So they try to go out Etham the sensible way, and maybe the guards didn't get the word, or the guards are just, they want to block them, so they have to go north and escape through the Yam Suf there, but then they go south. So the overall route, I simply used the traditional location of Mount Sinai in South Sinai. So from the view of Sinai and from Canaan, this would certainly be a south route. Yeah, there was that little hook to the north, that little detour we had to do, but it's a south route. So, Tel Ketewa today. That's where it happened. This is the bluff there. It's 4 meters above sea level, and the Ketewa Gap at this point is 1 meter above sea level. So that area there is where they scrambled ashore, watched the sun rise, and were exhausted, and Miriam sang the song of victory and played her tambourine, and they gathered there. This is, there's sort of some square there. I don't know what that is, but I can see that with Google Earth. So that's what I propose is the ending point of the crossing, is Tel Ketewa. And from there, then they go south, of course. So I've given you the latitude and longitude there, and I believe this presentation will be online, so you don't have to write down these things. So some final observations, the ask. So we have a difference of opinion over what the Lake of Tanis looked like, or even if it existed. What's the next logical experiment? I propose to take a north-south transect of sediment cores through the Ketewa Gap and out to the north to the present sea coast. That will determine the geography in 1250 BC. So I am a software engineer, an ocean modeler. Some expert has to extract and read the sediment cores. And now I'm going to quote Elrond, "One of you must do this." So I'd like to have somebody who will make those sediment cores. The sediment cores are very useful, but there's not enough of them, and they don't seem to be quite right along this yellow line. So that's the north-south transect of sediment cores that should establish what exactly that area looked like in 1250 BC. Any takers? Okay. So some concluding thoughts on the Exodus, and here I'm going to drift out of my area of expertise. I used the date of 1250 BC. I'm just following James Hoffmeyer and Kenneth Kitchen. That's the late date. The First Kings 6:1, the 480 years. If you do the math, I would think that 40 years are generations, and in the late Bronze Age, it's probably more like 23.6 years from firstborn son to firstborn son. It's not literally 40 years. So this date is okay with that. Now, as far as I'll wade in again, Exodus 14 and 15, I think they are both eyewitness accounts. I think they are different sources. I think the content is of the same age. I would say that the text of Exodus 15 is older because this was a beloved poem learned at their mother's knee. If you look in Christian churches today, you can find a bulletin where the Lord's Prayer is in King James English and the Psalm is in NIV. Does that mean that the Lord's Prayer is older? No, we know it's the reverse, whether it's post or pre-exilic. And so that is the same kind of thing that's happening there. Exodus 14 contains narrative details found nowhere else in any of literature. The wind direction, the timing of the event, and the insistence repeated that water was on left and right sides. The Song of the Sea says they went through it, but there isn't this. No, it was over there and back and forth again. So I know there are different sources in Exodus 14, but that is what I have used, and I think that it seems to be an eyewitness account because everybody who retells the story kind of leaves out the important meteorological stuff. So I did an estimate of, so we've heard this, that there are 600,000 fighting men. No way. That is way too many people. I used proxy measures and came up with 36,000 Israelites crossing the Red Sea using proxy measures of they're afraid of 600 plus chariots. They got 2 midwives, and Moses is learning to delegate and have a reasonable number of people for his direct reports. I've heard 10,000 bandied around here today, and I would be more comfortable with that number because 36,000 seems like a lot of people to get across, but that's the number I came up with. The problem is, as Kenneth Kitchen points out, when you see a number in Numbers 120 of 46,500, that should be read as 46 squads numbering 500 individual soldiers. So we have, Kenneth Kitchen has suggested a solution for a outrageous number of Israelites. And with that, I will be happy to take any questions, and I will be here throughout the entire conference, so we can talk to me anytime you like.
I have a question.
Yeah, Stephen.
Well, people love to be cited, so thank you. I appreciate that. I am curious about the Lake of Tanis, so maybe my question is to the Egyptologists. We've got Pitufi for Yamsu for Bala Lakes. We've got Sihor for the lagoon. Is there a Tanis Lake in Egyptian literature? Does anyone know the answer? Because I think there ought to be if it were there. I agree that using the Stanley cores, it's a little hard to pull that barrier out. And I think Wiesbrud and Snee had a little bit of a barrier on one of their maps. I'm not sure that.
Yeah, I saw that earlier. There was like a very small Lake of Tanis.
Yeah, so I just wondered, is there a record in Egyptian literature for a...
I'm sorry, I cannot provide the information right now. I to my knowledge, not, but I would need to look into some of the documents, Gautier's selection of geographic toponyms or so, to make sure that whether we have a toponym or not. It might well be. We certainly should have information, and I'm wondering that Jim Hoffmeyer has done so much research in the region. Has he come up with some data on Lake Tanis?
His maps all seem to stop a little bit north of like Pelusium, the latitude of Pelusium. Right, so yes. For most of them, I don't know what's up and to the left of his maps. Okay, so maybe that's just a desiderata for future research to go into that region. Mm-hmm.
Yeah, why do you need a barrier? Why do you need a barrier islands?
So I tried removing the barrier island, and you don't get nearly the crossing that you get with it there. So it is important for the hypothesis. Okay. If you blew a really strong wind and adjusted the direction, maybe you'd get a smaller, shorter crossing, but it is important. So that's sort of the most vulnerable part of the Tanis hypothesis, I would say. So that's the thing we need to test next.